Right, today in Algebra 2, we are going to finish up section 6.3. So we left off here at the bottom of this page of notes. We want to talk about solving equations with logarithms today. So it tells us that to solve an exponential, we're going to convert it to a logarithm. To solve a logarithm, we're going to convert it to an exponential. Solve each equation, round to the nearest thousand. Remember that thousandth is 3 decimal places. So number 1 says 25 equals 10 to the x minus 1 power. So this is an exponential, and it's not one that we know right off the top of our heads that we can pick a nice whole number and plug in for an x to make this work. So this is where if we cannot solve an exponential, okay, because it's not a nice whole number, then we need to take the log of both sides. So I'm going to take the log of 25 equals the log of 10 to the x minus 1. So all that we're doing is we're writing the word logarithm in front of both sides of the equation. Okay. So now on this side, I still have just the log of 25 equals over here. And again, we're using the log, the common log, and we need to remember that log of 10 is equal to 1 because this is understood to be base 10. So 10 to the first power equals 10. Okay, so this whole thing is just equal to 1, so it goes away. So then all I'm left on this side with is x minus 1. So now add 1 to both sides. So I have log of 25, all of that plus 1 equals x. That's what I'm going to type in my calculator. And I'm not going to round to the very end. So I'm going to type in log 25, hit enter, and then add 1 to that. And I get x is approximately 2.398. Okay, number 2, it starts out with a logarithm in the problem. Okay, and so here it tells me to solve a logarithm, we convert it to exponential. Remember, to convert to exponential is that little circle of life shortcut. So I take my base, I raise it to that power, it equals this. Since it's a natural log, remember my base is e, so I have e to the 4th equals 2x plus 3. I'm going to get x by itself, so I'm going to subtract 3 from both sides. E to the 4th minus 3 equals 2x. Divide by 2, divide by 2. I don't want to round until the very end, so I'm going to type in my calculator, e to the 4th, hit enter. Subtract 3, hit enter. Divide by 2, hit enter, and I get x is approximately 25.799. Don't forget that we can always check our answers, so if you wanted to check these, all you have to do is plug them back into the original equation. Okay. All right, number 3 starts out as a log, so I'm going to change it to an exponential. So my base to that power equals this. This time it's a log, doesn't have a base written, so it's understood to be base 10. So 10 squared equals 3x minus 2. So really I have 100 equals 3x minus 2. Add 2 to both sides, so I get 102 equals 3x. Divide by 3. This one is a nice whole number, x is equal to 34. Okay. I do need to check and make sure that since I started out the problem with the logarithm, I need to check it and make sure that I'm not going to end up with taking the log of a negative number here and it being extraneous. So 3 times 34 minus 2, that's going to give me a positive number, so I don't have to worry about that. Just remember, if whatever I got here, if I plugged it back in and it ended up being negative, I can't take the log of a negative number, so then it would be undefined, no solution. All right, number 4, I have an exponential, e to x plus 2 power equals 8. I have no idea, okay? That's not going to be a nice whole number, so I take the log of both sides. But since it's base e, I have to do the natural log of both sides. So ln e to the x plus 2 equals ln of 8. The natural log of e is equal to 1 because, again, e to the first power equals e. So on this side, that goes away, and I'm just left with x plus 2 equals the natural log of 8. So x is equal to the natural log of 8, and then I'm going to add 2 to that. So x is approximately, so in my calculator, I'm going to type in the natural log of 8, hit enter, and then, actually I just said plus 2, but this is going to be minus 2 when I move it to the other side. And then I'm going to subtract 2 from that. And so subtract 2, and now I can round, so I get x is approximately 0.079. So there's my answer. So now we're going to use what we just learned to solve some word problems, real life examples here. So it tells us the seismic energy X in joules can be estimated based on the magnitude M of an earthquake by the formula X equals 10 to the 1.5 M plus 12 power. Okay, so we have an exponential. What is the magnitude of an earthquake with a seismic energy of 4.2 times 10 to the 20th joules? Okay, so this is going to plug in right there for X, okay, because that's what the seismic energy is. So we're going to say 4.2 times 10 to the 20th equals 10 to the 1.5 M plus 12. We're trying to solve for M, right? The magnitude, that's what we're looking for. This is an exponential. I have no idea what number to plug in for M. This is not going to be a nice whole number, not a nice easy one. So we take the log of both sides. Log of 4.2 times 10 to the 20th equals log of 10 to the 1.5 M plus 12. And on this side, the log of 10 goes away because that's just 1. So I get the log of 4.2 times 10 to the 20th power equals 1.5 M plus 12. So I'm going to subtract 12 from both sides. So log of 4.2 times 10 to the 20th. Then I'll subtract 12. Then I'll divide by 1.5 to get M by itself. And I'm going to put this in the calculator in these steps. So I'm going to say M is approximately. So my calculator, I'm going to do the log 4.2 times 10 to the 20th equals minus 12 equals divided by 1.5 equals. And I find out that the magnitude is about 5.75. So that's a magnitude of about 5.75. We're going to do one more of those. What is the magnitude of an earthquake with a seismic energy of 1.8 times 10 to the 23rd joules? So 1.8 times 10 to the 23rd equals 10 to the 1.5 M plus 12. Again, I'm going to take the log of both sides. Again, the log of 10 goes away, it becomes just 1. So I have the log of 1.8 times 10 to the 23rd is equal to 1.5 M plus 12. So again, I'm going to subtract 12 and divide by 1.5. All of that minus 12 divided by 1.5 is equal to my M. So here I could say M is approximately, and again, I'm going to type this in steps. So log 1.8 times 10 to the 23rd equals minus 12 equals divide by 1.5, and I get M is approximately 7.5. So that's a pretty good little earthquake right there, a magnitude of 7.5. All right, so that finishes up section 6.3. We'll do our homework over this section, and then we will get a test review because we're going to take a test over the first 3 sections before we move on in chapter 6.